Hello everyone, welcome back to my channel. Today we'll be competing in a country ball challenge. Let's go. And also, please choose your country. I'm choosing Vietnam because, well, it's obvious. I live in Vietnam. Please comment down below what your country is. And let's start the video. Man, that's a lot of balls. So I think this will choose the team. And each team will have 26 players, so yep. Okay, I'm Team Orange. Okay, that kind of makes sense. Let's start the first challenge. So I've watched this before, and if the crusher crushes you, and then all of you move to the next round. But if you get crushed in this round, when they decide, they will eliminate all the crushed countries. Let's go. Ew. I'm gonna let you guys just see the purple crusher for a little bit. I'm gonna let you guys see the purple crusher. One orange? Oh, I'm so sorry. The yellow's doing so good. I wish I was in yellow. Just like I said, if you get crushed, you're eliminated. Let's go. Hey, orange. Yellow's cooking today.
This is the future.
Evolution.
This is the future.
Mine, you gotta lock in. Yes. And orange is cooking today. Oh, that's pink, not orange. Sorry guys. You guys also have to watch the ad, so yep, sorry. Goodbye. Goodbye, little ad. Chess. Oh, and when I was gone, dark green has been eliminated. What? Is that me? No. No, this can't be. Portugal died? Oh my god. The Portugal's Ronaldo's team. And they love Ronaldo. God is horrible. At least I'm surviving. And so that's not. Man, that's a lot of eliminated countries for light green. Man, that's a lot of eliminated countries for light green. Just like I said, time to make the decision of eliminations. And 2 people got eliminated on that team. Come the yellow team. Right off the bat, and also immediately, light blue just died. Dude, that was like 1 second into the challenge. Light blue just died. Oh my god, bro. Oh, was that another country? I think it was another country, but not light blue. Oh no, that was my team. Wait, no, that was not my team. That was orange. Sorry, guys. I thought my team was orange for a moment. There was a tough battle, and dark green takes it off. Come on, bro. You can do this. I believe in you. Come on. Just don't die for me. No, don't die. Don't die. No. I'm 10. Okay, 5 teams will walk away safe, but 3 teams will get eliminated. Okay, I'm gonna say goodbye. I'm gonna say goodbye so that you guys can see all of the colors. So, yep. See ya. Come on. Come on, yellow. Just die for me. Come on, you can do this. And that was a big jump for orange. That was a huge jump. I was watching this round and then I thought, maybe I should record a video. And now we're here. Yup, no second chances for dark green. No Thailand. No, that's the wrong way. That's the wrong way. You have to jump. That's the wrong way. You have to jump. Oh my God, bro! Just. Let's go. Thank you, Thailand. Oh my gosh. Only two more locks left. And then I'm out of here. Okay, I'm gonna speed this up because this is way too slow. Man, my computer is so laggy. And Thailand competes for the yellow team again. I wonder when will Vietnam compete for the yellow team. Yeah.
AdMob makes it easy to monetize your mobile game. Rewarded ads become part of the game, offering players value for...
Hey, Thailand has died. And there you go. And Dora has won it off. And my team just died. Whee! Real. Only one more luck left. And my computer's so laggy. Hả? Nhưng con không muốn đi ngủ. À.
The attacking infantry advances steadily, their elephants already having broken the defensive line. The king tries to retreat, but enemy cavalry flanks him from the rear. Escape is impossible. But this isn't a real war, nor is it just a game. Over the roughly 1.5 millennia of its existence, chess has been known as a tool of military strategy, a metaphor for human affairs, and a benchmark of genius. While our earliest records of chess are in the 7th century, legend tells that the game's origins lie a century earlier. Supposedly, when the youngest prince of the Gupta Empire was killed in battle, his brother devised a way of representing the scene to their grieving mother. Set on the 8x8 Ashtapada board, used for other popular pastimes, a new game emerged with 2 key features: different rules for moving different types of pieces, and a single king piece whose fate determined the outcome. The game was originally known as Chaturanga, a Sanskrit word for 4 divisions, but with its spread to Sassanid Persia, it acquired its current name and terminology: chess, derived from Shah, meaning king, and checkmate from Shah-mot, or the king is helpless. After the 7th century Islamic conquest of Persia, chess was introduced to the Arab world. Transcending its role as a tactical simulation, it eventually became a rich source of poetic imagery. Diplomats and courtiers used chess terms to describe political power. Ruling caliphs became avid players themselves, and historian al-Masudi considered the game a testament to human free will compared to games of chance. Medieval trade along the Silk Road carried the game to East and Southeast Asia, where many local variants developed. In China, chess pieces were placed at intersections of board squares, rather than inside them, as in the native strategy game Go. The reign of Mongol leader Tamerlane saw an 11x10 board with safe squares called citadels, and in Japanese shogi, captured pieces could be used by the opposing player. But it was in Europe that chess began to take on its modern form. By 1000 AD, the game had become part of courtly education. Chess was used as an allegory for different social classes performing their proper roles, and the pieces were reinterpreted in their new context. At the same time, the church remained suspicious of games. Moralists cautioned against devoting too much time to them, with chess even being briefly banned in France. Yet the game proliferated, and the 15th century saw it cohering into the form we know today. The relatively weak piece of advisor was recast as a more powerful queen, perhaps inspired by the recent surge of strong female leaders. This change accelerated the game's pace, and as other rules were popularized, treatises analyzing common openings and endgames appeared. Chess theory was born. With the Enlightenment era, the game moved from royal courts to coffee houses. Chess was now seen as an expression of creativity, encouraging bold moves and dramatic plays. This romantic style reached its peak in the immortal game of 1851, where Adolf Ondersin managed a checkmate after sacrificing his queen and both rooks. But the emergence of formal competitive play in the late 19th century meant that strategic calculation would eventually trump dramatic flair, and with the rise of international competition, chess took on a new geopolitical importance. During the Cold War, the Soviet Union devoted great resources to cultivating chess talent, dominating the championships for the rest of the century. But the player who would truly upset Russian dominance was not a citizen of another country, but an IBM computer called Deep Blue. Chess-playing computers had been developed for decades, but Deep Blue's triumph over Garry Kasparov in 1997 was the first time a machine had defeated a sitting champion. Today, chess software is capable of consistently defeating the best human players. But just like the game they've mastered, these machines are products of human ingenuity, and perhaps that same ingenuity will guide us out of this apparent checkmate. Did you know that the treadmill was originally designed to be a torture device? Learn more about its dark and twisted.
Sau khi diệp ích nhi giúp làm ẩm cơ thể, tránh nhiễm lạnh, một sản phẩm của Nam Dược, top 5 công ty đông dược uy tín.
The constant thud underneath your feet, the constrained space, and the monotony of going nowhere fast. It feels like hours have gone by, but it's only been 11 minutes. And you wonder, why am I torturing myself? This thing has got to be considered a cruel and unusual punishment. Actually, that's exactly what it is, or was. You see, in the 1800s, treadmills were created to punish English prisoners. At the time, the English prison system was abysmally bad. Execution and deportation were often the punishments of choice, and those who were locked away faced hours of solitude in filthy cells. So social movements led by religious groups, philanthropies, and celebrities like Charles Dickens sought to change these dire conditions and help reform the prisoners. When their movement succeeded, entire prisons were remodeled, and new forms of rehabilitation, such as the treadmill, were introduced. Here's how the original version, invented in 1818 by English engineer Sir William Cubitt, worked. Prisoners stepped on 24 spokes of a large paddle wheel. As the wheel turned, the prisoner was forced to keep stepping up or risk falling off, similar to modern stepper machines. Meanwhile, the rotation made gears pump out water, crush grain, or power mills, which is where the name treadmill originated. These devices were seen as a fantastic way of whipping prisoners into shape, and that added benefit of powering mills helped rebuild a British economy decimated by the Napoleonic Wars. It was a win for all concerned, except the prisoners. It's estimated that on average, prisoners spent 6 or so hours a day on treadmills, the equivalent of climbing 5,000 to 14,000 feet. 14,000 feet is roughly Mount Everest's halfway point. Imagine doing that 5 days a week with little food. Cubit's idea quickly spread across the British Empire and America. Within a decade of its creation, over 50 English prisons boasted a treadmill, and America a similar amount. Unsurprisingly, the exertion, combined with poor nutrition, saw many prisoners suffer breakdowns and injuries. Not that prison guards seemed to care. In 1824, New York prison guard James Hardy credited the device with taming his more boisterous inmates, writing that the monotonous steadiness, and not its severity, constitutes its terror. A quote many still agree with. And treadmills lasted in England until the late 19th century, when they were banned for being excessively cruel under the Prisons Act of 1898. But of course, the torture device returned with a vengeance, this time targeting the unsuspecting public. In 1911, a treadmill patent was registered in the US, and by 1952, the forerunner for today's modern treadmill had been created. When the jogging craze hit the US in the 1970s, the treadmill was thrust back into the limelight as an easy and convenient way to improve aerobic fitness and lose unwanted pounds, which, to be fair, it's pretty good at doing, and the machine has maintained its popularity since. So the next time you voluntarily subject yourself to what was once a cruel and unusual punishment, just be glad you can control when you'll hop off.
Japan's #1 electric hair care brand.
Every tree you've ever seen is dead. It turns out the alive part of a tree is just a tiny paper-thin strip of cells trapped between a dead skeleton and dead outsides. Trees are some of the most extreme beings on Earth, with one of the most unique strategies in nature. On top of being mostly dead stuff, they forge their body out of thin air, they mercilessly crush rocks with acid, and they have an internal negative pressure that would kill you instantly. So how do trees actually work? Let's go back to the beginning. The ancient battle for the sky. For over 1 billion years, the ancestors of plants only inhabited the sun-drenched surfaces of the oceans. Their bodies were thin and delicate and absorbed water straight through their surfaces, getting their energy through photosynthesis, forging sunlight, carbon dioxide and water into sugar. But about 470 million years ago, they decided to conquer a hostile alien planet, the land. Like green rugs with ambition, these plant ancestors began clinging to the ground wherever it was wet and damp. But now, with solid ground beneath and no ability to float around, a new dimension became a place of intense warfare. Up. The higher they grew, the more sun they would get, while starving their competition below. Height became a deadly weapon. The battle for the sky had begun. Until now, plants were built mostly from cellulose, which was great for shape but not for strength, which limited how tall they could grow. Over dozens of millions of years of evolutionary warfare, a group of plants developed one of life's greatest breakthroughs, lignin. Lignin is a macromolecule made of ring-shaped structures. It's rigid, tough, waterproof, and incredibly hard to break down. Concrete in a world made of jelly. It filled gaps between cellulose threads, stiffening and locking everything into place. Lignin gave plants the strength to grow taller and claim the sun for themselves. But of course, now they were competing with each other, which must have been really annoying for them. So, as more millions of years passed, some plants just went all in on lignin and produced more and more of it, becoming stiffer, harder, and stronger. Until one day, around 385 million years ago, they got the biological equivalent to steel-reinforced concrete, wood. More on it later, but with this magic material, the first trees emerged. Almost immediately, they became the largest living beings alive, shooting up to 20 meters high into the sky, and they only got bigger from here. But this enormous size created extremely hard problems. How do you get water from the ground up to the green parts that do the actual photosynthesis? And how do you get the sugar they produce down to the cells that keep you up there? On the scale of a cell, a distance of a few meters is like you're working in Britain while your lunchbox is in Egypt and your drink in New York. How do you not die? So trees came up with one of the most amazing ways any organism grows and became nearly immortal by accident. A conveyor belt of death. Let's slice an ancient tree in half and get to the heart running it all. The cambium, a razor-thin, circular zone just a few stem cells wide. These stem cells grow inward and outwards, turning into two groups of specialists. The inward specialists are on a conveyor belt of death, the xylem. With each new division, it's pushing the cambium outwards, making the tree thicker the older it gets. As the xylem cells mature, their lignin production goes into overdrive, and they become hard, like a muscle slowly transforming into bone. They begin to hollow themselves out, shedding everything that once made them alive, and then they die. What's left is a corpse, a hard, empty tube. As the tree grows year after year, new corpses are layered on old corpses, forming rings of hardened dead tissue. A graveyard of trillions of plant bones. This is what we call wood. Stacked together, they form a giant network of pipes that stretches the whole length of the tree. This network uses the chemical properties of water and a few other tricks to move it with incredible efficiency. Water molecules are, for a lack of a better word, sticky, like tiny magnets, and naturally cling tightly to each other. When one moves, it pulls the next along with it, like pulling on a rope. In trees, this rope starts in the roots and ends in the leaves that bathe in the warmth from the sun. Here, the heat from the sun evaporates 95% of the water that got sucked into the roots from billions of tiny pores, releasing a constant invisible mist of water molecules around the crown of the tree. This process, called transpiration in plants, creates tension on the rope of water molecules, stretching and lifting the entire column upwards all the way from the roots to the leaves. This pull is so insanely strong that it can lift water over 100 meters, which requires sucking forces equivalent to the pressure of dozens of atmospheres, as much as the crushing pressure hundreds of meters deep in the ocean. Our first ever PC game, Starbirds, is out now in early access. Find out more at the end of this video. Imagine, a stadium-sized asteroid is going to hit Earth in 2 weeks. Even at this moderate size, a fireball brighter than the sun tears through the atmosphere at 60 times the speed of sound, and the destructive power of 4,000 Hiroshima bombs flattens cities, killing millions. This isn't science fiction. Many killer asteroids were only spotted at the last moment. In 2019, asteroid OK, as big as a 30-story building, was discovered just 1 day before it grazed Earth closer than some of our satellites. Last year, the even larger asteroid MK was spotted 13 days before it passed us closer than the Moon. If they'd have hit Earth, they would have unleashed the destructive power of 3,000 and 9,000 Hiroshima bombs. Stunningly enough, humanity doesn't really have a plan for this. Scientists have devised all kinds of tricks to push dangerous asteroids away, painting it so sunlight will deflect it, landing thrusters to steer it, scorching it with lasers, or even crashing spacecraft into it. But they all have a big problem. They're the equivalent of trying to deflect a cargo ship by throwing a bag of potatoes at it. They do move the asteroid, but only by a tiny bit. With these methods, you need to act years or even decades in advance to make an asteroid miss the Earth. But very recently, scientists have developed a new, spectacular way to destroy killer asteroids that we could implement with today's technology. Let's see how this works with our 100-meter asteroid heading for Earth. The secret weakness of asteroids. For a long time, people imagined asteroids as being gigantic stones made of rock and metal. But it turns out most of them aren't like that. They're more like bags of loosely packed gravel, heaps of pebbles, precious minerals, and dust barely held as much as the crushing pressure hundreds of meters deep in the ocean. Nothing humans have ever built comes even close to this power. Even our best machines can't pull. Here in the Kurzgesagt labs, we only work on the most important scientific problems like, what if we nuke stuff? Or how about we make this elephant explode? Or, who could forget, look at this thing, it's really big. Continuing this proud tradition, let's explore the scientific mystery of what would happen to you if Earth suddenly turned into gold. The Midas Apocalypse, based on the ancient tale of King Midas, who was cursed so everything he touched turned into gold. Before we can explore this scenario with science, we'll first define the premise. Midas's curse is a very special phenomenon called magic, which allows us to modify physics. So what happens when Midas touches something and it turns to gold? An atom of gold has 79 protons and 118 neutrons in its nucleus. The electric force of the protons on the electrons around them shapes the atom and gives gold its chemical properties, like that it doesn't rust and that it's kind of shiny and bendy. So, to make not gold into gold, we have to change atoms. Let's say Midas touches a duck. Touches a duck. All the light elements like hydrogen, carbon and oxygen gain electrons and protons and neutrons to become gold. Not only is the duck suddenly 33 times more massive, it's also much too dense. The gold atoms are far closer together than they like and repel each other violently, causing the golden duck to explode with the energy of half a ton of TNT, leaving only gold dust and a very dead Midas. This is clearly not a very good way for Midas's power to work. So what if instead Midas's power uses the atoms that are already present and simply rearranges all particles in the matter he touches into gold? No matter is created or destroyed. Instead, atoms dissolve and the protons, neutrons and electrons are reassembled to make gold. However, gold is very dense, about 20 times denser than a duck. Without adding any matter, the gold duck would be a very awkward kind of foamy gold with lots of tiny microscopic gaps. This is funky and doesn't explode, which is progress. Now that we've established a sort of magic that works, what would happen if Midas stumbles? What if he touches Earth itself? Let's freeze time for just a moment and rearrange all the matter in the Earth. Just like the duck, the Earth is now solid gold, but with many tiny atomic scale gaps. While these gaps weren't a huge deal for the duck, they're a big problem for the Earth. A spongy planet is not a thing that can exist, as gravity compresses Earth, squeezing it together to close up the gaps. As a result, the Earth contracts, shrinking to 2/3 of its radius. If you're standing on Earth's surface, you'll suddenly find yourself in freefall, like on a roller coaster, as the ground sinks away beneath you. But since the ground is falling too, it doesn't move away from you. It feels like someone turned off gravity, and you and everything else would begin to float. But the ride doesn't last forever. It takes only 10 minutes for everything to crash down, and a weird 10 minutes it is indeed. And then, as abruptly as it started, it stops. The collapsing Earth has reached its desired size, and gravity is suddenly turned back on for you. Hopefully you enjoyed your minutes of floating, because the ground and you with it crash into the planet at 30,000 kilometers an hour, making your body splatter like a water balloon as it hits. In one instant, basically all of humanity gets smashed into red puddles. This is only the start of our problems though, since Earth imploded supersonically. The kinetic energy of the implosion is basically equivalent to detonating a planet made of TNT. Crushed together under incredible forces, Earth's core reaches 1,000,000 degrees Celsius.
Mỗi thùng Omachi tiếng trống hồi xuân là một lời chúc mùa xuân đổi mới. Cho nhan sắc đổi mới, cho tình duyên nở rộ. Mang Omachi về nhà, đón mùa xuân đổi mới.
Would you trust your life in the full...
Okay, I'm gonna let you guys watch this. I'm gonna go to the toilet now.
opposable
So,
thumbs of the
goodbye.
balloon? Well, if you were aboard a train bound for Cape Town in the 1880s, there's a good chance that that was exactly what you were doing. Meet Jack the Signal Man. A baboon responsible for preventing trains from crashing into each other. But who gave him this important job in the first place? Well, it all started with a man named James Jumper Wide. He was a signalman who was famous for jumping between rail cars until he fell and lost both of his legs. Although he built himself some pegs for legs and a makeshift wheelchair, Jumper thought his career as a signalman was over. Until he stumbled across Jack the Baboon, who had been trained to push an ox cart. After much begging and pleading with the owner, he bought Jack the Baboon and took him home. Jack turned out to be an alcoholic and refused to do anything unless he was given a few drops of booze. And so, with enough encouragement, Jumper was able to train him to push his wheelchair to work. Don't drink and drive, kids. Jack would watch Jumper hard at work at the levers every single day. Approaching trains would blow a certain number of whistles, which corresponded to the track they wanted to be transferred to. And Jumper would hobble around with great difficulty and set the right levers for the train. And just by observing, Jack was able to learn and memorize these sequences. It didn't take long till Jumper let him try flipping the levers himself, and soon, Jumper had given the monkey full control. But it didn't take long for railway authorities to receive a complaint from a passenger, and after confirming the ridiculousness for themselves, they fired the pair on the spot. Jumper pleaded with authorities to let Jack prove his abilities, and after harassing them for days, they eventually agreed to give him a chance. And Jack's performance left them speechless. In fact, Jack had performed so well that they made him an official employee of the railway, with a salary of 20 cents a day and a half a bottle of beer weekly. I don't know what Jack needed the money for, but he definitely made good use of that alcohol. And after being employed for 9 years in the railway, Jack never made a single mistake, performing his job even better than a human could. He eventually died of tuberculosis in 1890, and his skull resides in Albany Museum to this day.
Oh, but memorizing a bunch of lever positions is easy.
Well, why don't we play a memory game then? I'm gonna show you 5 random numbers between 1 and 9, and I'll hide them after a short amount of time, and you need to recall their positions in ascending order. We'll start easy. Ready, set, go. Okay, so get your answers ready now. If it was 2, 3, 6, 8, and 9, then good job. I think most of you got that. Now, let's ramp up the difficulty. Ready, set, go. Yeah, I'm gonna guess none of you got that one. But guess what? Ayumu the chimpanzee did. Ayumu is a part of...
I got it right. So that means... Do I get a prize? Do I get a prize? That? Chosen death? Huh? Mobia. Oh, Mobia. I love Jack. So in reality, there's no prize.
the eye research project in Kyoto University, and he's really good at this memory test. I mean, look at that speed. Look at that technique. The project was actually started to research Ayumu's mom, Chimpanzee Eye, the first chimp in the world able to represent numbers with Arabic numerals, and she even liked to paint for fun. So naturally, big brain mom birds big brain son. Ayumu answered the memory test correctly with an accuracy of 79% on average, maintaining his accuracy even with shorter test times. This was compared to human subjects on the same test, and, well, this is what their graph looked like. These results made it seem like young chimpanzees have a much better working memory than humans, but some scientists disagreed with this, saying,
They will have more practice time.
so in another experiment, the humans were given more time to practice the task first, and after 2,500 trials, they were just able to match a Yumu's accuracy levels. I expected a bit more out of the humans, to be honest. Shouldn't they be way better with numbers than a chimpanzee?
Bắn quá gà, nhạc quá, dễ hơn với chiến thuật này. Bắt đầu chỉ bằng một con dao.
I did a bit more out of the humans, to be honest. Shouldn't they be way better with numbers than a chimpanzee? Well, speaking of numbers, Clever Hans was a horse from Berlin in the 1900s, who seemingly had the ability to do quick math. His owner would ask him a question, and Clever Hans would answer by tapping his hoof the correct number of times. Seems a bit sus, and the German Board of Education thought so too, because they conducted an official scientific investigation into Hans's abilities. A man named Oscar Funks designed the experiment, and hypothesized that Hans's owner was sneakily sending him signals. So he made a random stranger ask the questions instead, but Hans was still able to nail the answers. Perplexed? Funks then used blinders on Hans so he couldn't see the questioner, and his ability to answer the questions plummeted. In some cases, he would even keep tapping his hoof on the ground indefinitely. But why couldn't he answer correctly when he couldn't see the questioner? Funks had an idea. He asked Hans a question that he himself didn't know the answer to, and amazingly, Hans proceeded to do this again. The conclusion Funks came to was that Hans was able to pick up on subtle, involuntary gestures from the questioner when his answer reached the right number. He was so good at detecting these minute postural changes that the questioners themselves were totally unaware that they were doing them. So Hans may not have been a big brain maths genius, but he was a genius at reading people's body language. Something humans themselves are notoriously bad at. Could you imagine Hans as a detective, though? I don't know. I swear. This whole occurrence coined the term the Clever Hans effect, where an animal predicts what someone wants them to do without actually understanding their own actions. For this reason, it's important to conduct animal experiments in a double-blind fashion, where nobody knows what the expected results are. Oh, hey Alex. In 1977, animal psychologist Dr. Irene Pepperberg bought an African grey parrot from a pet store. She named him Alex, short for Avian Learning Experiment. And over the next 30 years, she proceeded to make him the smartest animal in the world. Alex had a spoken vocabulary of over 100 words, but instead of just imitating words, he seemed to have an understanding of what they actually meant. He could label objects correctly based on their shape, size, color, or material, and even created his own words, like when he was shown an apple for the first time and called it a banary, combining two words he had already learned, banana and cherry. Ooh, look at the smart bird brain. Alex also showed genuine anger or surprise when the researchers tried to trick him during tests. If Alex asked for a banana and they gave him a nut instead, he would throw it back. Foolish human. He also got frustrated with his fellow research buddies when they answered wrong. How many blocks are there? 4? The freakiest part was when he looked in the mirror one day and asked,
What color?
This was the first instance in history of an animal subject asking a question. That too, an existential one.
Why are we still here? Just to suffer.
There's plenty of past examples of animals communicating with humans using sign language and whatnot, but not a single one has asked a question. It's always been, give food, give drink, leave me human, and give food. The cutest thing was that every night before Dr. Pepperberg locked the lab up, Alex would say,
You be good. I love you. See you tomorrow.
and those would be his last words before unexpectedly passing away one night, at the age of 31. So far, all of these smart animals have been in some form of captivity, but what about a big brain animal in the wild? In the late 1800s, ships had great difficulty navigating a treacherous stretch of water called Cook Strait. It was notorious for wrecking ships, and sailors were terrified of passing through. One day, as a ship named the Brindle approached, the crew saw a Risso's dolphin bobbing happily in front of them. And of course, as humans always do, they proceeded to try and kill him. Thankfully, the captain's wife managed to talk them out of it, but to their surprise, despite the threats to his life, the derpy dolphin began to guide the ship safely through the dangerous waters. And from that day onwards, he did the same for every ship passing through. He was given the name Pelorus Jack. When he navigated, not a single shipwreck occurred. Sailors would even refuse to enter the strait unless Pelorus Jack had appeared to guide them. This continued until 1904, when someone aboard the SS Penguin fired their rifle at the dolphin. Pelorus Jack was injured, and he disappeared. The people were devastated, and a law was passed under the Sea Fisheries Act, protecting him from any other attacks on his life. I wouldn't be surprised if he decided to never help out a human again, but on one fateful day, Pelorus Jack reappeared. Hey guys. He was a kind-hearted, forgiving creature, ready to help out humans in need again. Except for the SS Penguin, which ended up shipwrecked in the same waters in 1905. And after being a companion to sailors for over 24 years, Pelorus Jack was last seen in April of 1912. There were various speculations about his disappearance, but I'd like to think that he found a nice place to retire in after a long, fulfilling life. He seemed like a pretty cool dude and is fondly remembered as a hero to many New Zealanders. It's really amazing how all these animals were so smart, and it's also amazing how I am a dumb doggo. See you next time.
Chất lượng cao, an toàn, dịch vụ tốt, xe máy. Độc đỏ vị mới. Thử vị khác biệt, vượt trên giới hạn.
Japan quality.
Humans have adapted to the most extreme environments on Earth over thousands of generations. And then there's you. Me? And your only adaptation is this pudgy tubby. Let's see how you compare against real superhumans from extreme environments. Number 7. Superhumans of the Deep Sea. First, we're heading to the islands of Southeast Asia. And remember, the deep sea is very dangerous for regular people like you. Let's see how long you last. The moment your face hits the cold water, your diving reflex kicks in. Your heart rate slows by up to 25% to save energy. Your blood vessels constrict, redirecting blood to vital organs, and your spleen acts as a biological scuba tank, pumping extra oxygen-rich blood cells into your bloodstream. But despite all these amazing adaptations, you're dead. 2 minutes. Not bad, but not even close to the superhumans of the sea, the Summer Bajau people, who are the closest we have to Aquaman. They live a hunter-gatherer lifestyle and have been reported to be able to hold their breath underwater for over 10 minutes at a time, spending a total of almost 8 hours a day submerged underwater. They have extremely low body fat, making them negatively buoyant, allowing them to run effortlessly across the seabed to hunt fish. You, on the other hand, are extremely positively buoyant. As you go deeper underwater, pressure increases significantly, and diving deep too quickly can cause your eardrums to tear. Regular divers prevent this by gently blowing through their ears to equalize pressure, but the Summer Bajau say, who needs eardrums? They purposely obliterate their eardrums at a young age, so they basically have no ear pressure problems. Only ear hearing problems. When you're underwater for too long, carbon dioxide levels in your blood begin to rise. This triggers the body's panic reflex, causing you to take a fresh breath of water. The Summer Bajau, however, have a gene mutation that suppresses this reflex, allowing them to stay calm underwater for longer. Other genetic mutations they have include a gene which provides increased constriction of their blood vessels, and one which gives them a spleen that's 50% larger than regular humans. Anyways, let's get out of here, because we got 6 more superhumans to learn about. You know, you might not be some crazy genetic superhuman, but you do use one superpower every day, and that's Opera Browser, who's the sponsor of today's video. Opera One R2 is designed to give you an effortless browsing experience. Do you ever lose that one special tab in the 50 bajillion tabs you have open? Where did it go? Well, with Opera's Tab Traces feature, you can easily find recently opened tabs with the subtle underscore symbol. Oh, there you are. Also, the Tab Island feature automatically groups tabs based on context, so you can collapse tabs you're not using and focus on what's important. Alright, so how does this work again? Is constantly flipping between windows annoying you? Well, the split screen feature allows you to work on 2 pages at the same time, and all in the same window. The themes feature also makes the browser super customizable, including animated backgrounds, unique UI colors, browser sounds, and more. You can even use Aria, the inbuilt AI, to ask questions, for image recognition, and to even generate images from scratch. And finally, the floating music player makes it super easy to control your music without interrupting your browsing. Upgrade to a better browser today by clicking the link in the description below, and thanks to Opera for sponsoring this video. Now, where were we? Number 6, Superhumans of the Jungle. Welcome to the African rainforest in the Congo Basin, where everything wants to either bite you, sting you, infect you, or eat you. The thick rainforest canopy above blocks most sunlight, making it incredibly easy to get lost. The air is hot and very humid, to the point where your sweat can't even evaporate to cool you down. So instead, you continue to heat up, causing you to sweat some more, heat up, sweat, die of dehydration. But don't worry, the superhumans of the rainforest are here to save the day. Standing at a mighty 4 feet and 11 inches tall, the African pygmies make their small stature their superpower. Being this small allows the pygmies to generate less heat and sweat, reducing the chance of dehydration, while also making it easier to navigate the dense undergrowth. In an environment where food is scarce, a compact body requires less resources to survive. But sometimes the pygmies stumble upon the ultimate jackpot, a beehive filled with delicious honey. But there's a catch. It's 40 meters up a tree. Armed with nothing but an axe and a loop of tree vine, the pygmies fearlessly scale the tree, hacking footholds in as they go. And after battling a bunch of bees, they finally secure the goods.
Food, finally.
On to the next location. No, wait. Oh yeah, and like the video, it's free. Number 5, Superhumans of the Ice. We're zooming all the way out to the Arctic, where the warmest days are 10 degrees Celsius and the coldest days are minus 40 degrees Celsius. When your body temperature drops below 35 degrees Celsius, you start to experience hypothermia. First comes the shivering, and your blood vessels constrict to keep vital organs warm. But this causes your extremities to become too cold, making them freeze and die due to frostbite. At this point, your brain has probably started to fail too, causing confusion, memory loss, and maybe even some fun hallucinations. Some people get so delirious that they actually strip naked, which sure helps them keep warm. That's where the superhumans of the ice come in, the Inuit people. Their short, stocky build minimizes surface area, helping them retain more heat. They also have more blood rushing through their fingers and toes, reducing the chance of frostbite freezing them off. By consuming fatty meat from seals and fish, they build up an insulating layer of fat. But while most people primarily have white fat, the Inuit people have an abundance of brown fat, which is packed with specialized mitochondria, the powerhouse of the cell, turning them into a human furnace. Because of all these adaptations, the Inuit people can maintain a metabolic rate of up to 200% higher than an average person, meaning they're able to maintain a toasty core temperature without even needing to shiver. But don't worry, the next location will definitely warm you up.
X-Men tắm gội Aqua Sport mới. Sách cầu định. Hương Phương Tình.
Warm you up. Number 4, Superhumans of the Desert. Now we're on the opposite side of the temperature spectrum, the scorching hot African desert, and you're giving us a lovely demonstration of hyperthermia in action. First comes the heat exhaustion, heavy sweating, rapid breathing, and your pulse racing. Your blood vessels also dilate, trying desperately to dump heat through your skin. But eventually, you progress to heat stroke, where you become so dehydrated that you stop sweating entirely. Your organs start to fail, and your brain starts shutting down, leading to confusion, aggression, seizures, and finally, unconsciousness before you die. But these extreme conditions are no problem for the superhumans of the desert, the Maasai tribe. They average around 6 feet tall and have longer, skinnier limbs that help with better heat dissipation through more surface area. They also have a crazy diet of raw meat, raw milk, and raw blood from cows, which helps them maintain their extremely low body fat and naturally lower body temperature. And their dark skin provides stronger protection against sunburn. All of these adaptations help them sweat and pee less than normal people to conserve water. And one more superpower is that these guys can jump super high.
Looking a bit thirsty there, aren't you? Well, let's get you something to drink.
Number 3, superhumans of poison. Next, we find ourselves in the Andes Mountains at Uru Uru Lake in Bolivia, which is known for being full of toxic arsenic. Arsenic naturally occurs in volcanic rock, but rain and mining operations release significant amounts of it into the surrounding rivers and lakes. And now, that toxic arsenic is in you. First, your body tries to get rid of the toxins through both exits. Then comes the numbness, abdominal pain, and muscle cramps. With long-term exposure, your skin color changes, and lesions start popping up on your skin. You start developing hard patches in your palms and the soles of your feet, and not to mention the increased risk of cancer, diabetes, and heart problems too. So why isn't she dying yet? Well, that's because over thousands of years, the Uru people have developed a genetic cheat code for poison resistance. The AS3MT gene helps detoxify arsenic, allowing the Uru people to pee it out faster. So it spends less time in their body, meaning less harmful effects on their health. But rising pollution levels, frequent drying up of the lakes, and long-term exposure to arsenic have unfortunately forced many Uru people to abandon their homes in recent times. But I hope you're all hydrated now, because we're off to even higher mountains. Number 2, superhumans of the mountains. We're at Mount Everest Base Camp, 5,000 meters above sea level. Well, I guess that makes sense, because at elevations of just 2,500 meters, many people start experiencing altitude sickness. The air up here is thin, and has way less oxygen than your body is used to, which leads to headaches, dizziness, and vomiting. And in extreme cases, fluid can build up in your lungs and brain, causing shortness of breath, severe confusion, and even death. Even being physically fit won't save you up here. Not that that's relevant in your case, but there have been instances where highly trained mountaineers have died from altitude sickness. The real superhumans are the ones that accompany these mountaineers, the Sherpa. They're able to pull in more oxygen than the average person due to their naturally larger lung capacity and faster breathing. A gene mutation also allows them to use this oxygen more efficiently, giving them superior stamina. It's for these reasons that the Sherpas are a necessity for people looking to summit Mount Everest. They lead the climbs, carry heavy loads, and provide first aid, all while your sorry butt is struggling to survive. But we made it though. Wow, look at that view. That's where we're going next. Number 1, superhumans of space. Our final destination, the International Space Station. In this zero-gravity environment, there's no load being placed on your body, so it says, hey, I don't really need me anymore, do I? And then it proceeds to turn your muscles to jelly and weaken your bones. Zero gravity changes your blood distribution too, giving you a balloon head and chicken legs. Even with our fancy space station shielding, you're getting bombarded with over 50 times the radiation down Earth. And because microgravity messes up how your digestive system works, a lot more too. Ugh. Right now, there are no superhumans that have genetically adapted to life in space. But rather than waiting for natural selection to take its course over thousands of years, let's borrow from all the superhumans we've met so far. In you go. First, we'll add a Sherpa in for genes with better oxygen efficiency, and a Sama Bajau in for superior breath-holding abilities. From the Maasai tribe, we'll grab the genes that help conserve water, but not the height genes. Can you sit down? Instead, we'll take the Pygmy's compact and lightweight build, as it requires less resources to sustain and also saves on rocket fuel. We can't forget the mutations from this video, the DLX3 gene for indestructible bones, and the MSTN gene for super strength and muscle preservation. And for radiation resistance, there's research which shows that extra P53 genes help to repair and protect DNA from damage. And lastly, why not throw in some plant DNA too, to allow you to create food via photosynthesis. Back to space. Wakey, wakey. How you doing?
I feel powerful, Papa.
Oh yeah, I didn't fix your flatulence.
I see. Thank you, Papa.
See ya next time.
Watch this one next.
Gặp gỡ vị mới. Thử vị khác biệt, vượt trên giới hạn.
And also remember to like and subscribe.
Did you know you can't just dig up your great-great-great-great-grandma and call her a fossil? You're only a fossil if you're from a past geological age. So, your remains need to remain for thousands or even millions of years. But there's more than one way to become a fossil, and I've got 7 for you to try right now. Number 1, permineralization. This is the most common type, and almost all dinosaur fossils you see at the museum have formed through this process. But if you want to become a fossil, first you'll need to become a corpse. In most cases, scavengers will find and pick you apart, so for protection, you'll need a rapid burial. Being buried also cuts off the oxygen, which bacteria need to decompose you. Low oxygen equals low decay, which preserves you for longer. Over time, your soft tissues will usually still decay, but solid parts like your bones and teeth remain, ready for...
Begin.
It actually starts in the sky. Rain is usually slightly acidic, and when it seeps into the ground, it dissolves minerals like silica from the soil. The silica-rich groundwater eventually reaches your remains and enters the pores of your bones, where the silica precipitates on all surfaces, inside and out, coating them with a fresh layer of mineral paint. Over hundreds of thousands of years, this forms a protective layer of stone around the bone, creating a permineralized fossil. But in another process called mineral replacement, the silica can replace the original bone minerals themselves. If all the bone minerals are swapped out, it becomes a petrified fossil, essentially meaning it's completely turned to stone. Apart from petrified dinosaur bones, you can find petrified shells, wood, or even poop. I don't know about that one. And it's not just silica. These processes can happen with other minerals too. Like, here's a cool rock I have with glow-in-the-dark fossils in it. And there's also pyrite ones that form shiny metallic-looking fossils. A little to the right. Ooh, a bit to the left. All right, bring it down, boys. Time to find more exhibits. Number 2, amber. In a coniferous forest 140 million years ago, a bug-sized human is busy chewing through a poor tree when suddenly a sticky orange goo oozes out. This is resin, the tree's active defense, and it's used to seal wounds to protect against further damage or infection. Eventually, the resin fully engulfs you, forming a nice airtight seal. And as a bonus, it also contains toxic terpene molecules, which act like a natural bug spray. So even if you don't suffocate to death, you're dead either way. Blech. Over the following days, the resin hardens via a process called polymerization, becoming a semi-solid substance known as copal. If left above the surface, it eventually degrades and decomposes. But luckily in this case, the hardening has caused it to break off and fall to the forest floor, to be slowly buried over the next thousands of years. In the absence of UV light and oxygen, the copal is able to harden completely over time, eventually turning into amber, which is a tough material that resists decay, perfectly preserving whatever was trapped inside. Amber fossils usually contain tiny bugs like ants and flies. My favorite one is the spider frozen in time attacking a wasp, roughly 100 million years ago. Now, all that's left to do is excavate the amber, polish it up, and then... wow! Look at that! A perfect specimen. Number 3, carbonization. We'll need you to be a plant for this one. So one day you're just chilling, doing whatever plants do, when... boom, mudslide kills you. You've been rapidly buried and the oxygen is cut off. Perfect conditions for fossilization. Over the years, more sediment piles on top, eventually burying you 3 kilometers underground. You'd be experiencing 800 times atmospheric pressure here. That's like the heat and pressure squeeze out all compounds containing hydrogen oxide.
Các bạn xin hãy like và đăng ký và tạm biệt các bạn.